Hello, Pratt & Whitney Fire Rescue. I'm coming to you via the training room, and I put together a small video on a Sunday, which this is a great day to film a video. And this video is going to cover our new Draeger monitors that we've taken delivery of. I'm really happy about the fact and excited about the fact that we have our own monitors now, and that we can call our own, and that we can take some ownership over and have accountability for, and that was kind of the whole reason we bought our own monitors. And so moving forward, I see this as a real improvement to a more robust monitoring program that Pratt & Whitney Fire Rescue is going to have throughout the plant site, and we're going to be delivering an improved service to all our internal customers at Pratt & Whitney. So with that said, I don't really need to go into the history of monitoring that we had here previous to it, other than I think there were improvements that could have been made, and I think with the delivery of these new monitors, we're going to have some pretty unique improvements, and I think moving forward we're going to be even better off than we were before. We wanted to have more control over calibration, over bump testing, and over annual maintenance of our own monitors, and having our own assures us of that. So I'm very excited about that. The monitors we received are Draeger XAM 5000 monitors. They are identical to the monitors that were used at Aerojet Rocketdyne in E-Area. We made some changes. We like the changes that we've made on this monitor, and I think you will too. And I'm going to cover some of those changes, and then just some monitoring basics to hopefully kind of just get us back into hazmat school mode a little bit, and to remind us on, some of the basics of monitoring and how we should be using these. The typical industry standard for monitoring was a 4-gas meter, and so the XAM 5000 is an improvement on that. It's a 5-gas meter, so that's really good. And we need that 5th gas on the plant site, because we have hydrogen here that we monitor for regularly, and that is going to be considered our 5th gas. It's built into these new monitors. Okay. The other 4 gases, as you know, are oxygen, carbon monoxide, the lower explosive limit, or LEL, and hydrogen sulfide. Okay, those are the typical 4 gases that you'd find on any 4-gas monitor. With the exception of ours, we have a 5th gas, which is hydrogen, which we would consider H2. And that's, and the reason I bring up H2 is because it would be easy to confuse on a monitor screen H2 and H2S. Okay, so there's a big difference. One of our 4 gases on this monitor is hydrogen sulfide, right? Swamp gas. It smells really bad, like it's that smell you smell at the dump when you drive by it. That's hydrogen sulfide. That gas is H2S as opposed to just H2. So when you look at it on the monitor screen, don't get confused by those two, which can easily be done. So we have a 5-gas monitor. These monitors are very simple to use. They are almost firefighter proof, if I was going to put something out there for monitor's sake. Normal values on these are typically 0, except for oxygen. And your oxygen sensor should be reading 20.9% O2 as a normal reading for daily use. Although some on the plant site will say that there is an allowable threshold for hydrogen when you're monitoring. Okay, some say 200 parts per million or up to 400 parts per million of hydrogen is an acceptable threshold. From what I've been told and from what everyone has told me here at the plant, any presence of hydrogen while monitoring is going to be unacceptable, and no one's going to initiate any kind of work or hot work if we've got hydrogen readings of any type. So they're going to take those extra steps to inert that pipe or whatever is reading hydrogen and get that down to 0 before they start their processes. So that's really important for us, and having a good monitor that we know has been bump tested in the morning, first thing, that we know has been fresh air calibrated before we actually do the monitoring. That's going to make a big difference in the confidence we have in the monitoring readings that we are going to obtain either on a call or on a routine basis when we're sniffing in the different areas on the plant site. So I'm going to fire up our monitor. This is the XAM 5000. Okay, I know that you guys have used this many times over, and a lot of this is going to be a review for you. I'm not trying to insult your intelligence, but I do want to go over the basics of this again, just as like you've never seen the monitor before. And you never know. You may pick up a tidbit of information that you didn't know about previously. And so don't think I'm insulting your intelligence. I know everybody can use this monitor. So to power this on, you're going to hold down. There's a green button, an OK button that's green, and then a plus button that's blue. Okay, so if I hold down the green button, it counts down to 3. Oh, that was a blooper. If you don't hold it down, it'll just turn off on you, which that's what's happening to me. Okay, I'm going to try it again. Okay, there we go. And so it powers up. And then what you'll notice is different things appear on the screen. All your sensors will come up. You'll see all kinds of numbers flashing. And what it's doing is it's conducting its own self-test. And it's actually running through the different sensors in here. And it's showing you the values of each sensor as far as when they're going to alarm. Okay, it's not really important to sit there and watch these unless you're wanting to know at what thresholds they'll alarm at and how they've been set up. But basically, this is just doing a self-test. And you'll notice that red LED lights flashing on here. Okay, that's just to kind of give you a heads up that, yeah, everything's working fine. And then, when they're done, you're going to see that. Okay, so if I press the OK button, it'll light up the backlight on the LED screen. And those are your values, okay? So everything is at 0 except for oxygen, which is at 20.9%. If this monitor runs low on batteries, it typically will take about 4 hours to recharge. So at the end of the day, when we're done with this, we're going to put them back in the chargers. We've got a charger for each one. And that's pretty much it for cranking up the monitor. Once that self-test is done, then it is in monitoring mode. It will monitor. If I took this downrange on a gas leak call without a pump attached to it, then which is called diffusion mode, by the way. So gas will still enter this monitor through the front here, up at the top. You'll see these little circles, and those are the sensors. And gas will pass over those sensors and then create a reading in the monitor. So you don't necessarily need the pump, although the pump is much more accurate, especially when you're point source monitoring an area like we do very often. So the pump is a great thing to have, okay? Not always needed on an emergency incident, okay? It will do its job without having the pump, okay? So sometimes we'll just clip this to our bunker coat or have it in hand, and it'll still monitor successfully in that situation. If we want to turn off the monitor, then you're going to hold down the green and the blue buttons simultaneously, and you'll see it counts down 3, 2, 1. You'll get a little audible and a visual, and then the monitor's off. Make sure you power this off before you put it in the charger, very important. And that's pretty much it for turning on and off. You guys already know this. I know it's just a review, but I thought it'd be pretty good to just review that. Remember, your oxygen should be at 20.9%. All other values are at 0. And then this will have 2 different alarms on it for each sensor, an A1 alarm and an A2 alarm. The A1 alarm, okay, is an alarm that's going to tell us that whatever gas we're monitoring, if it goes off, we're in an IDLH environment. And that's really important, okay, because at that point, we've got some decisions to make. And we may want to back out and just, reevaluate our plan. But the bottom line is, and the reason I say the A1 alarm is so important is because if we're on an emergency call and we're monitoring an area for maybe a flammable gas, then if we get an A1 alarm, it's imperative that we are wearing full bunker gear and be on air, okay? Because let's face it, if we're not on air and we're monitoring, and now all of a sudden we've got an A1 alarm going off, which is you're going to hear an audio and a visual on this. You'll see A1 flash on the screen. Then you're you're definitely in an IDLH environment, and you don't want to be not on air and in full bunker gear if you're in an IDLH environment. So just something to think about before you go down range and monitor for any of the gases that are, that this monitor is designed to look for. An A2 alarm is an even higher concentration, okay, of whatever this is set for, whatever gas that you're monitoring is set for. So in that case, you have a much higher concentration of gas, extremely hazardous environment, and how you'll know that is A2 will flash on the screen with the reading, and you won't be able to silence that, okay? Typically on an A1 alarm, if you press the green OK button, you can silence the audible on that alarm. With an A2 alarm, you won't be able to do that, okay? So that should be a pretty clear and present sign that, you know what, maybe we need to back out and reevaluate and maybe, reassess and make a new plan. So that's something to think about with A1 and A2 alarms on this. If you ever see any L-shaped symbols that come up in the right-hand column of the monitor next to a sensor, it typically will mean that the sensor has been exceeded or it's been saturated with a gas, okay? And that sensor is no longer working properly, so you'd have to back out or use another monitor until you can correct the problem. Whenever you see negative number values near a sensor, it typically means that you need to fresh air calibrate the monitor. And we're going to go over that later on in the video. But just know that if you got negative numbers, that's not correct. You've always got to have zeros before you start your monitoring process. Please bump test your monitor each morning before you leave the station to do your routine sniffs in test area. And that's really, really going to be important. That's something we hadn't done previously because our monitors were in another area of the plant site. But now we've got them in the fire station. They will be fully charged and ready to go. And we have what's called an X-Dock station. And the X-Dock station actually conducts a routine every morning bump test on each monitor that you're going to take out of the station with you. And another change that we're instituting is that you're not just going to take one of these, you're going to take two of them. Okay, we want a backup monitor. If we get positive readings, we're going to want to use that backup monitor to double check those readings. And you never know, these things, they may foul up, one of them may foul up, and you're going to need a backup. Okay, so if that does happen, 2 monitors every morning before you go down to the test area to do your routine sniffs, and that way we're covered. Okay, and the plan is to get 5 of these total, 5 XAM 5000s and 5 pumps to go with each monitor. So we'll have a pretty robust monitoring program once we get all that delivered and up and running. But for now we have 3, and we're off to a really good start. Regarding oxygen concentrations, I wanted to talk about this because it's something we may be tempted to disregard, but it's really, really important in the hazardous materials world. Remember, oxygen concentration being normally read at 20.9%. Okay, if that reading falls below 20.9%, that means something is displacing the oxygen that we're reading on the screen. And all our other values on here may read 0, but that may only mean that whatever's displacing that oxygen is not actually read by this monitor. Okay, it may be another gas that this monitor won't see. That is really, really important. So when we get decreased oxygen levels, below 20.9%, then we should be suspect that something's displacing that oxygen, okay? And it may be in a pretty high concentration as well, even if it's just a small decrease in oxygen content. So keep that in mind. We learned that in hazmat school. This is not going to activate as far as oxygen goes until you reach 19.5%, which is a pretty low amount of oxygen. And then if you have an enriched oxygen atmosphere, it's going to alarm at 23.5%. Remember, 1% of anything in air could be up to 10,000 parts per million, right? 1% is 10,000 parts per million. So that means something is displacing that oxygen that could be up to 10,000 parts per million. And that would definitely be worth backing out, talking about it, and coming up with a plan to further investigate that reading. So keep that in mind when it comes to the oxygen sensor. It's really important. The LEL sensor on this, or the lower explosive limit sensor on this, reads in a percentage as well. All the other sensors read in parts per million, but your LEL and your O2 read in percentage, okay? Oh, the other thing that's really important about this is that when you calibrate this in the morning, there are two calibration gases that are attached to the X-Dock station. And they have all the different gases that this monitor will monitor for, okay? So those gases will actually enter this monitor in the morning when you hook it up to the X-Dock station to do the morning bump test, okay? The LEL sensor, or the lower explosive limit sensor on this, is calibrated to methane. And methane, as you guys know, is natural gas, okay, which we have plenty of here on the plant site. But because the sensor is calibrated to methane, any other flammable gas that we might monitor on the plant site, we would have to use a conversion factor, okay, and multiply that reading by the conversion factor to get an accurate reading. Because if it was propane, it would be a completely different number based on a conversion factor. So just keep that in mind. This is calibrated for methane. And we have two different alarms on this monitor for each sensor. What we call an A1 alarm and an A2 alarm. And that's really important to know, because an A1 alarm is your first warning. That's when your audible is going to go off, your visual, your LEDs are going to go off on the monitor, and that's the first sign that you are in an IDLH environment. And the reason, well, we've already talked about it, but the reason that's really, really important is because we need to be in full PPE if that happens. The A1 alarm on the Draeger XAM 5000 is set to 10% of the lower explosive limit when it comes to monitoring for flammability. So an A1 alarm at 10% of that LEL is considered by OSHA to be an IDLH environment. The takeaway there, wear your PPE, be on air, don't get surprised because you may be in an IDLH environment. The A2 alarm would be set to about 20% of the LEL on our monitors, and that's a much higher concentration of gas. And that would prompt us to maybe exit the area and do some assessment of things before we move on. Another thing that is a common mistake with these by emergency responders is that if they have a known gas leak and they know the origin of the gas leak, where it is, they want to walk right up on it, okay, with the monitor. And all that's going to do is oversaturate the monitor, and then it really, from that point on, it becomes useless. I've seen it done time and time again. And it's really important that in those scenarios where we know what the gas is and we know where the gas leak is, that we don't approach it with the monitor. In those cases, outskirt monitoring is what's most important with this, okay? That's where you're monitoring downwind, or you're monitoring around an area around the leak, and you're determining what the levels are, where you would set up your hot, your warm, and your cold zones to keep people out and keep people safe. So the other thing that we had delivered is our our pump for the XAM 5000. These pumps are a lot sturdier and better made than the previous pumps. The previous pumps had some pretty brittle plastic parts on them, and we did have problems with some of those parts breaking off, and then the monitor wouldn't snap into the pump like it should have. So these are a lot sturdier, and I think they're going to see not nearly as much wear and tear as the previous ones did. The difference with these is these cradle pumps will plug in to a charger. So when we get back to the station after a day of monitoring, we will plug these in and have them, charged up for the next day. All right. And you'll see about 3 foot of monitoring tubing here, and then your typical telescoping wand. All this stuff is new. So it came with our order, and I'm really I'm stoked about the fact that we've got some brand new equipment. Okay. So once again, I'm going to power up the monitor by holding the green button down for 3 seconds, continuous. Then it's going to go through its self-test. You should hear the audible. You should see the visual LEDs go off. That's pretty important. It's just something you want to note in the morning that the monitor is operating correctly. And then you're going to let it, it takes about 30, 40 seconds to get through its self-test. But the monitor has to be on before you actually put it in the pump. That's important. You'll notice a picture of the XAM 5000 here on the pump. This is the top of the pump. So you're going to orient it with the picture on top. And it looks like our self-test is done. So this is the important part. When you look at the Draeger XAM 5000, you have this little ring here, right? And that ring can flip up against the monitor, or it can flip down, right? And then maybe you could attach a carabiner on here and then clip it to something like your belt or your coat. So you want to make sure that that ring is flipped in the down position. Otherwise, this is not going to seat properly into the pump, all right? If you have the ring up here like this, it makes the pump thicker and it won't go in there and seat properly. So make sure this is down like this, and then you're going to take your pump, all right, and you're going to slide it directly in. Okay, once it makes contact, then you'll hear it go off. You'll hear the pump crank up automatically, and you'll see the LED lights go on. Then I'm going to take the clip here and push it to the back until it snaps in place. A really, really good attachment there. Now you'll notice I need to kink my hose. So I'm going to take that little picture there, says kink your hose. I'm going to kink it, release it. And that didn't work right. Once again, there's your hose. Now keep the hose. Let it go. There we go. And now we're back to monitoring mode. Okay. So now I'm ready to monitor. All right. So that's really important as far as how that works. Just make sure you kink the hose. And we've always done that on the previous pumps, so that works really good. So in order to turn the pump off, I'm going to release the back clip and then just slide the monitor out. When I do, the monitor is going to, the pump is going to continue to run for a little bit, maybe an extra 10, 15 seconds, and then it just shut off, okay? And that's important because if you leave the pump and the monitor attached to each other, then you're going to run the battery down on both of them. So make sure when you're done with the pump that you disconnect it from the monitor. Keep the two separated and they won't be using battery. Once you disconnect the monitor from the pump, then you should go back to normal readings. Okay. Now we're back in diffusion mode. So this will still work without the pump as far as monitoring goes. One of the last things I want to go over is how to fresh air calibrate the Draeger XAM 5000. And that's going to be important right before we do our monitoring, just to assure that all our sensors are zeroed out. We don't have any negative numbers or any kind of symbols that indicate that there's something wrong with the monitor. If there is, we won't use it. We'll rely on a backup, and we'll do the majority of our monitoring that way. So back to fresh air calibrating. This is something we want to do in a clean environment. So we don't want to do it around any engines that are running, no diesel or gasoline engines running in the area. Make sure that you do it in a clean area. That way, whatever it's pulling in during the fresh air calibration is actually clean air. That's really important. So in order to enter that mode for fresh air calibration, we're going to leave the measuring mode. So right now it's in measuring mode. It's showing the oxygen and then zeros on all the other sensors. Okay, so to get out of measuring mode, we're going to look at the blue plus button. We're going to hit that 3 times real fast. 1, 2, 3. And then you're going to hear a beep. And you're going to notice that the word cal at the top of the screen is actually darkened and highlighted. Okay, and that means it's ready to be fresh air calibrated. Okay, so the calibration symbol is already highlighted. And then we just want to hit OK. Okay. And then OK again a second time. And what we'll see is everything will be blinking OK. All right, and then it will return to the screen. To get out of the measuring mode, we just push the plus button 1 time, and then we're back to measuring mode. Okay? So we want to do this fresh air calibration before any monitoring that we do. So it's a bump test in the morning at the station before we leave, but then when we get downrange and test area and we're doing some routine sniffing, we're going to do our fresh air calibration down there just to make sure that everything is zeroed out and ready to go. Very important. Okay. The X-Dock station, let's talk a little bit about that. The X-Dock station is something we purchased because we wanted to be able to do some of our own internal maintenance on the monitor and maintain it in good working order. So before you dock a monitor into the X-Dock station, you want to turn on the cal gases that run that station. So behind the station, you notice there's 2 canisters connected to the X-Dock station with some tubing. So you want to turn those on before you actually do any kind of X-Dock work, because those calibration gases need to run into the X-Dock. So we're going to keep them off when we're not using the X-Dock, which is most of the time. So you're just going to be using that X-Dock for a couple of minutes every morning, and then you're done with it. Make sure when you're done, you turn the cal gas off on each bottle. So make sure the cal gas is cranked on, and then you're going to power up the X-Dock, and then you're just going to put the monitor in the X-Dock, and you're going to shut the lid down on top of it. And what you'll notice is when the test starts, you're going to see a blue screen. You're going to see a flashing blue LED strip down below the monitor. You're going to see the monitor's name on the screen. It's a touch screen, so just tap that monitor. You'll see XAM 5000, just tap it. And then once you do that, it will start its bump test. If it passes the bump test, then you should get a green screen and a green LED bar below the monitor. Once you see that, you can lift the lid of the X-Dock and pull the monitor out, and it has been successfully bump tested, and it's ready to go for the day. And you're going to do that for each monitor in the morning. If you get a red screen and a red LED bar below the monitor, that means that something went wrong, and that your monitor is not ready to go, so you're not going to use that monitor for the day until we figure out what's wrong with it. The X-Dock station is linked to the laptop in the training room that runs SimMan. We have X-Dock's software installed on there, and when we call in the Draeger rep annually to do our calibrations, span calibrations, and just to do an annual checkup, we'll end up using that laptop that's connected to the Xtalk station. The Draeger Rep has the ability to make configuration changes to the monitor, software updates, anything like that. So any of the changes that we have upon request, the Draeger Rep will come out and help us out with that stuff, as well as the annual checkup. And that's pretty much all I have for this video. I know it was a little bit longer than maybe you wanted it to be, but I wanted to cover some pretty essential parts of this new monitoring program. And I think that moving forward, if you guys have any ideas about this, please let me know. I'm just one brain here trying to, take input from everyone, including our special ops specialists on each shift. So it's been a group effort, and I just want to make sure that we have the best monitoring program we can have and that's safe for the plant and our property sites. So if you guys have any other ideas or improvements we can make, please give me a holler. I'm all ears. I definitely want to make it best we can make it.